Hello everyone. In our today's session, we're going to take up the familiarization with apparatus and equipment used in testing of materials. In order to start, let me introduce to you the different types of civil engineering material testing. And the following are: first, we have the test on cements, test on coarse aggregates, test on fine aggregates, test on fresh concrete, test on hardened concrete, test on soil, test on bricks, test on bitumen, and test on reinforcement. To start with, let us have the test on cements, and here are the following. We have a type of experiment, and we call it as the fineness test, or the fineness of cement. The test is done for finding the fineness of cement by sieving the cement on the standard IS sieve, and it's called as the fineness test of cement. The proportion of cement size greater than 90 microns is considered as finest cement. In other words, the fineness of the cement is the particle size of cement. Then we also have the consistency test, or the normal consistency of cement. The standard consistency of cement by the BICAT apparatus. The consistency of cement is the minimum water requirement to start the chemical reaction between water and cement. This test helps to identify the minimum water required to make the cement paste. And why do we do cement consistency test? The cement starts hydrating when it reacts with the water and hardens itself actually. The third one, we also have the initial and final setting test, or the initial and final setting of cement. The initial setting time is the exact moment when the concrete starts to harden. In theory, this time starts as soon as the water is added to the cement. The final setting time is the moment the concrete is hardened enough so that a 5mm square needle no longer penetrates the surface. Any cement paste requirement of minimum water in cement paste for initiate the chemical reaction. This chemical reaction now is called the consistency of cement. This method called the consistency of cement test. Then we also have the soundness test. It determines an aggregate's resistance to disintegration by weathering, and in particular, freeze-thaw cycles. Aggregates that are durable, meaning resistant to weathering, are less likely to degrade in the field and cause premature HMA pavement distress and potentially failure. What is the purpose of soundness test then? Soundness test of aggregates by IS 2386 Part 5. Objective: this test is intended to study the resistance of coarse and fine aggregates to weathering action and to judge the durability of the coarse aggregate. Test on coarse aggregates, and here are the following. First, we have the sieve analysis test. This is to determine the size distribution of particles. The sieve analysis test procedure is an effective method that prevailed from the past. In sieve analysis, the particle size distribution is defined using the mass or volume. Sieve analysis is a laboratory test procedure in which particles will move vertically or horizontally through sieve mesh. The purpose? A test used to determine the particle size of fine and coarse aggregate is known as the sieve analysis test. Collected sample aggregates are thoroughly sieved through appropriate IS sieve to determine the particle size. And then we also have the water absorption test. It gives an idea on the internal structure of aggregate. Aggregates having more absorption are more porous in nature and are generally considered unsuitable, unless found to be acceptable based on strength, impact, and hardness tests. Aggregate abrasion test. The aim of aggregate abrasion test is to determine the measure of the resistance of aggregate to the surface wear by abrasion, and also to assess the durability of the pavement surfacing when traversed by many repetitions of truck wheel load or many different kinds of moving loads. Then we also have the aggregate impact value. It is actually the ability of aggregates that resist sudden impact or shock load on it. Also, it can be defined as the resistance of aggregate to failure by impact load, and it is known as the impact value of the aggregate. Aggregate casting value or pricing value is a numerical index of the strength of the aggregate, and it is used in construction of roads and pavements. Crushing value of aggregates indicates its strength. Lower crushing value is recommended for roads and pavement, as it indicates a lower crush fraction under load and would give a longer service life and a more economical performance. Aggregate crushing value test on coarse aggregate gives a relative measure of the resistance of an aggregate crushing under gradually applied compressive load. Coarse aggregate crushing value is the percentage by weight of the crushed material obtained when test aggregates are subjected to a specified load under a standardized condition. Aggregate crushing value is a numerical index of the strength of the aggregate, and it is used in construction of roads and pavements. Crushing value of aggregates indicates its strength. Lower crushing value is recommended for roads and pavements, as it indicates a lower crush fraction under load and would give a longer service life and more economical performance. The aggregates used in roads and pavement construction must be strong enough to withstand crushing under roller and traffic. If the aggregate crushing value is 30 or higher, the result may be anomalous, and in such cases the 10% fines value should be determined instead. Now let us proceed to the test on fine aggregates. Sieve test. It is actually a sieve analysis, and it is a practice or procedure used in civil engineering and chemical engineering to assess the particle size distribution, also called gradation, of granular material by allowing the material to pass through a sieves or series of sieves of progressively smaller mesh size and weighing the amount of material that is stopped by each sieve as a fraction of the whole mass. The size distribution is often of critical importance to the way of the material performs in use. A sieve analysis can be performed on any type of non-organic or organic granular materials, including sand, crushed rock, clay, granite, feldspar, coal, soil, a wide range of manufactured powder, grain and seeds, down to a minimum size depending on the exact method. Being such a simple technique of particle sizing, it is probably the most common. Then we also have the specific gravity test under fine aggregates. Have you wondered why some objects sink while others float? Many factors come into play in determining if an object will sink or float, and specific gravity is one of the main deciding factors. Let us now understand what is the specific gravity in detail. Specific gravity, or known as relative gravity, is actually a dimensionless quantity that is defined as the ratio of the density of the substance to the density of water at the specified temperature and pressure. Water absorption test. It gives an idea on the internal structure of aggregate. Aggregates having more absorption are more porous in nature and are generally considered unsuitable unless found to be acceptable based on strength, impact, and hardness tests. A test to determine the moisture content of soil as a percentage of its dry weight, according to British Standard 1377, 1967, the sample is weighed, dried in an oven, then reweighed under standard condition. It is calculated as the moisture content, which is equal to the weight of the container with wet soil minus the weight of the container with dry soil, divided by weight of the container with dry soil minus the weight of the container, then multiplied by 100 to express it as a percentage. Then we also have the bulk density test. It is a test wherein it is a classification test carried out for cohesive soils. It is the mass of the soil sample per unit volume including voids, or the weight of the soil sample for a given volume. It is also used to measure the degree of soil compaction and to calculate the porosity and void ratio when the specific gravity of the sample is known. Soundness test determines an aggregate resistance to disintegration by weathering and, in particular, freeze-thaw cycles. Aggregates that are durable, resistant to weathering, are less likely to degrade in the field and cause premature HMA, pavement, distress, and potentially failure. The soundness test repeatedly submerges an aggregate sample in a sodium sulfate or magnesium sulfate solution. This process causes salt crystals to form in the aggregate's water-permeable pores. The formation of these crystals creates internal forces that apply pressure on aggregate pores and tend to break the aggregate, as we can see from figure 1 below, after a specified number of submerging and drying repetitions. The aggregate is sieved to determine the percent loss of material. Silt and clay test. Since silts are considerably more permeable than clays, the dilatancy or shaking test may also be used to distinguish between the two materials. In this test, a small amount of soil is mixed with water to a very soft consistency in the palm of the hand. The back of the hand is then lightly tapped. The silt test is carried out to determine the amount of silt, clay, or other fine dust that may be present in a sand sample. The presence of such in a sand used in concrete will reduce the strength of the hardened concrete if exceeds a permitted limit. On-site identification of silt and clay. The distinction between silt and clay cannot be based on particle size because the significant physical properties of the two materials are related only indirectly to the size of particles. Furthermore, since both are microscopic, physical properties other than particle size must be used as criteria for field identification. There are 4 numbers of field tests that we can easily conduct on the field to identify silt and clay, and these are the following: dry strength, the latency or shaking test, toughness to plasticity, and dispersion. So this is our figure 1, as shown below. From gravel to sand to silt and to clay. Dry strength test. It provides one basis for distinction. A small briquette of the soil is molded and allowed to dry in the air. It is then broken and a small fragment about 1 centimeter in size is pressed between thumb and forefinger. The effort required to break the fragment provides a basis for describing the strength as very low, low, medium, high, or very high. A clay fragment can be broken only with great effort, or a silt fragment processed easily. Then we also have the shaking test. Since silts are considerably more permeable than clays, shaking tests may also be used to distinguish between two materials. In this test, a small amount of soil is mixed with water to a very soft consistency in the palm of the hand. The back of the hand is then lightly tapped. If the soil is silty, water rises quickly to its surface and gives it a shiny or glistening appearance. Then, if the soil path is deformed, in some instances by squeezing and in others by stretching, the water flows back into it and leaves the surface with a dull appearance. Usually, the greater the proportion of clay in the sample, the slower the reaction to the test. The reaction is described as rapid, slow, or none. We have now the toughness or the plasticity test. The property of plasticity is characteristic of clays and may be used as the basis for a simple field test. At certain moisture contents, as soil or a soil that contains appreciable quantities of clay can be deformed and remolded in the hand without disintegration. Thus, if a sample of moist soil can be manipulated between the palms of the hands and fingers and roll out into a long thread, it is unquestionably contains a significant amount of clay. As moisture is lost during continued manipulation, the soil approaches an non-plastic condition and becomes crumbly. Just before the crumbly state is reached, a highly plastic clay can be rolled into a long thread with a diameter of approximately 3 millimeters, which has sufficient strength to support its own weight. Silt, on the other hand, can seldom be rolled into a thread with a diameter as small as 3 millimeters without severe cracking, and is completely lacking the tensile strength unless small amounts of clay are present. The record of a simply plasticity test should indicate not only whether a plastic thread can be formed, but also the toughness of the thread as it nears the crumbling stage. This condition is described as weak and friable, medium, or tough. Let us have now the dispersion test, the fourth procedure, known as the dispersion test. It is also useful for distinguishing between silt and clay, and for making a rough estimate of the relative amount of sands, silt, and clay in a material. A small quantity of the soil is dispersed with water in a glass cylinder or test tube, and then allowed to settle. The coarser particles fall out first, and the finest particles remain in suspension the longest. Ordinarily, sand settles in 30 to 60 seconds. Materials of silt size settles in 15 to 60 minutes, whereas that of clay size remains in suspension for at least several hours, and usually for several days unless the particles of clay combine in group of floccles. Number one, in chemistry, a small aggregate of flocculent material, something resembling a type of full. Test on pressed concrete. We have the workability test. According to AZI, workability is defined as the haze with which concrete can be mixed, placed, consolidated, and finished. A mix that is difficult to place and consolidate will increase the cost of handling and lead to poor strength, durability, and appearance. Since it is practically impossible to devise test methods that can simultaneously check all these characteristics, the measurement of the workability of a concrete mixture is obtained indirectly through its consistency. As per AZI, consistency is the relative mobility or ability of fresh mixed concrete to flow. It is indicative of the wetness of the mix. Usually, wetter mixes are more workable. However, there can be exemptions to this rule. As a general rule, consistency of concrete should be no more than necessary for placing, compacting, and finishing. Water requirement for a given consistency depends mostly on aggregate characteristics in's to increase cohesiveness and finishability of concrete. The fine to coarse aggregate ratio should be increased rather than increasing proportions of fine particles in the fine aggregate. For mixes requiring high consistency, use of water-reducing admixtures should be considered rather than adding more water. For high-strength concrete, as low width is to be maintained, the workability should be achieved by use of admixtures such as water reducers and air entrainers. Common workability tests are the slump test, compaction factor test, flow test, Bevy test, and other field tests like the Kelly ball test and the K-tester probe. Figure 2 shows the slump test, which is the most common technique for evaluating workability across the world. In the settlement of concrete from a molten truncated cone, shape is measured and called as the slump. Whether mixes possess greater slump. However, sometimes mixes with ice lump need not show good workability. For example, wet mix with, a low proportion of fineness will show ice lump, but would be harsh to one. So this is now the slump test, and as we can see here in figure 2, so that we can even imagine how to, at least how to imagine or how to apply the slump test. The slump test cannot be adequately measure the workability of steep and dry mixes. The Bebe test is better suited for this purpose. Here, vibration is applied to convert a truncated cone of concrete to a cylindrical shape, and the time taken for this is measured. Water mixes require lesser time. The apparatus for the Bebe test is shown in figure 3. Next slide. After this slide. Two other common workability tests are the compaction factor test and the flow table test. In the compaction factor test, a given volume of concrete undergoes free fall from one hopper to the second, and then into a cylindrical container, as we can see at figure 4 in our following slide. The compactability of the concrete is measured from the mass of the concrete inside the cylindrical container, without and with vibration, and subsequent filling. On the other hand, the flow table test involves the spread of truncated cone of concrete on table that is dropped a number of times, or dropped a number of times. So we have now the figure 3 of Bebe test apparatus, so that you can be familiarized, and the compaction factor test apparatus. And then we have another apparatus here, and we call it as the flow table test apparatus. Literature suggests that the results from different consistency measurements compare as per table 1. As we can see here in this table, comparison of different consistency methods by using different tests. On the first column, we have the workability description. Second, we have the slump, BB, and the compacting factor and their corresponding values in every category, from extremely dry, very steep, plastic, and flowing. And then, as shown below, we have the compacting factor test and the BB test. Test on hardened concrete. Non-destructive test is a wide group of analysis techniques used in science and technology industry to evaluate the properties of a material, component, or system without causing damage. And then we also have the rebound hammer test. It is a non-destructive testing method of concrete which provides a convenient and rapid indication of the compressive strength of the concrete. The rebound hammer is also called as Midge hammer that consists of a spring control mass that slides on the plunger with a tubular housing. Then we also have the ultrasonic pulse velocity test. In situ, non-destructive test to check the quality of concrete and natural rocks. In this test, the strength and quality of concrete or rock is assessed by measuring the velocity of an ultrasonic pulse passing through a concrete structure or natural rock formation. This test is conducted by passing a pulse of ultrasonic through concrete to be tested and measuring the time taken by pulse to get through the structure. Higher velocities indicate good quality and continuity of the material, while slower velocities may indicate concrete with many cracks or voids. Ultrasonic testing equipment includes a pulse generation circuit consisting of electronic circuit for generating pulses and a transducer for transforming electronic pulse into a mechanical pulse having an oscillation frequency in range 40 kHz to 50 kHz, and a pulse reception circuit that receives the signal. The transducer, clock, oscillation circuit, and power source are assembled for use. After calibration to a standard sample of material with known properties, the transducers are placed on opposite sides of the material. Pulse velocity is measured by a simple formula. Ultrasonic pulse velocity can be used to the following: evaluate the quality and homogeneity of concrete materials, predict the strength of concrete, evaluate the dynamic modulus of elasticity of concrete, estimate the depth of cracks in concrete, detect internal flows, cracks, honeycombing, and coarse patches, poor patches. The test can also be used to evaluate the effectiveness of crack repair. Ultrasonic testing is an indicative, and other tests such as destructive testing must be conducted to find the structural and mechanical properties of the material. We also have the compression test. It is actually any test in which a material experiences opposing forces that push inward upon the specimen from opposite sides or is otherwise compressed, squashed, crushed, or flattened. The test sample is generally placed in between two plates that distribute the applied load across the entire surface area of two opposite pieces of the test and sample, and then the plates are pushed together by a universal testing machine, causing the sample to flatten. A compressed sample is usually shortened in the direction of the applied forces and expands in the direction perpendicular to the force. A compression test is essentially the opposite of the more common tension test or tensile test. Test on soil. For road construction works, the properties of soil at subgrade level are required. The common soil test for road construction includes classification of soil, particle size distribution, moisture content determination, specific gravity, liquid limit, and plastic limit tests. Moisture content, particle size, and specific gravity tests on soils are used for the calculation of soil properties such as degree of saturation. The soil test can be laboratory test or in situ test. The laboratory test should be carried out on every sample taken for the determination of particle size and the moisture content. The water content test, particle size distribution test. This test determines the particle size distribution of soil from the coarse and sand size down to fine clay size. The data from the particle size distribution test is used to determine the suitability of soil for road construction, airfield, etc. This test can also be used to predict soil water movement, although permeability tests are more generally used. Liquid limit test, plastic limit test, freeze-wall index, specific gravity test, maximum dry density test. Then we also have the types of soil tests for road construction. Following are the various types of soil tests for pavement construction. In situ, moisture content is carried out in the laboratory. It is expressed as the percentage of water in the soil to its dry mass. The moisture content in soil signifies the various properties of soil, such as compaction, permeability, particle size, and etc. Specific gravity of soil is the ratio of the weight of soil in the air of a given volume at a standard temperature to the weight in air of an equal volume of distilled water at the same stated temperature. This test is also carried out in the laboratory. Particle size distribution by wet sieving and pipette method. This test determines the particle size distribution of soil from the coarse sand size down to fine clay size. The data from the particle size distribution test is used to determine the suitability of soil for road construction, airfield, etc. This test can also be used to predict soil water movement, although permeability tests are more generally used. Then we also have the compaction test or Proctor test. The soil compaction test, also called as Proctor test, is used for the determination of the mass of dry soil per cubic meter when the soil is compacted over a range of moisture contents, giving the maximum dry density at optimum moisture content. Thus, this test provides the compaction characteristics of different soils with changing moisture content. This is achieved by the densification of soil by reducing the air voids. The degree is measured in terms of its dry density of soil. The dry density is maximum at the optimum water content. California bearing ratio test is conducted in the laboratory. This test provides the load penetration resistance of the soil, and it is obtained by measuring the relationship between force and penetration when a cylindrical plunger is made to penetrate the soil at standard rate. It is used for the evaluation of the subgrade strength of roads and pavements. Its value obtained by this test is used with the empirical curves to determine the thickness of pavement and its component layers. This is the most widely used method for the design of taxable pavement, even though the provision of subsoil drains reduces the effect of water on the subgrade. What is so severe tests shall be considered to be appropriate for road construction projects. The following points should be taken care of while soil testing for road construction. Sample and testing. Sampling of soil for tests in laboratory or in situ is to be carefully done by an experienced engineer. The requirement for the various mass or volume of soil at different points of a road project shall be followed as per the specification and standard codes. Test data logging of all the sample or soil sample and test data shall be done by trained staff who has the knowledge of soil properties and test results. Testing frequency of soil shall be as per input from engineer. The decision on the testing frequency is usually taken on the basis of results obtained from the previous test. Test on brick. Water absorption test. A test to determine the moisture content of soil as a percentage of its dry weight. The sample is weighed, dried, and oven, then weighed under standard condition. Crushing strength test. The hardness test. Shape and size test. Soundness test. A fluorescence test. And item number 8, we have the following. Test on bitumen. Number 1, we have the specific gravity test, Marshall stability test, penetration test, plus and parpon test, softening test, ductility test, and last but not the least, test on reinforcement. So we have the following test: the tensile, yield stress, percentage elongation test, bend and ribbon, and chemical analysis test. And that's all for today. Thank you and God bless us all.